A thief is in a sinister, diabolical, fiendish, dark, circular dungeon with three identical doors. Once the thief chooses a door and passes through it, the door locks behind him. The three doors lead to a 6-hour tunnel that leads to freedom, a 3-hour tunnel that returns him to the dungeon, a 9-hour tunnel that returns him to the dungeon. Each door is chosen with equal probability. When he is dropped back into the dungeon by the second and third doors, he is a Markov thief in the sense that there is a memoryless choice of the doors. He isn't able to mark the doors in any way. Uh, what is his expected time to escape? Mm, we we solve draw a graphic of Markov by the Markov, and he choose if he choose 6 hour doors, a freedom, and 3 hour and 9 hour. With dungeon at 3 hour that returns him to the dungeon, and 6 hour that leads to the freedom. So x best way to proceed is to let x be a random variable, which is time to get to freedom, and to define probability mass function for this race variable, and you will see that this is not a simple task at also. First of all, what is the quickest way to get to freedom? Well, that's x equals 6 hours. If he chooses the correct door to take him to freedom, and that occurs with probability 1/3, the second way to get to freedom take 9 hours, and that's if he chooses the short tunnel, and that occurs with probability correctness occurs with probability 1/3 square, because he's no next thing, take him 12 hour, and we get 12 hour and 1 hour cubed, and we get x equals 15, and 1/3 and 4th. So that fashion, that was the tricking along 1/3. 4th is the probability that, but could also choose the 9-hour tunnel followed by 6-hour tunnel, and that would also get him out in 15 hours. So you have to add in 1/3 squared, and so it goes with x equals 18, etc, etc. So we can write by that. And why to calculate expected value of x, which is the sum over the script of which are all of these x values of x times f of x. But you could imagine that right there might be a very difficult way to solve the problem, because it is so difficult. So put together probability mass function now using conditional expectation. So we can solve that. I'm going to condition on the first door choice, and the way this works is to find this expected time to escape. Escape. You look at the conditional expectation given his first door choice was door number 1, the one that led to freedom, and you weight that by the probability that door 1 is chosen, and then you add to that the expected value of x given that he chose door 2 as his first door choice times. So we can write x door second and p door second. Finally, the expected value of x given he chose door 3, which had the long tunnel associated with it, times the probability of choosing door 3 now. Yes. into the equation on the left hand side you have expected value of x. What is the expected value of x given he choose the first door? And well, it's clear the expected value of x is just 6 hour, so we can write there uh, 1 over 3 plus and x given the initial choices door. Well, if he chooses door second, he's going to spend 3 hours in the tunnel, then he's plopped right back into the dungeon, and it's like starting over. So in this particular case we can say this is 3, yeah, 3 more for the short tunnel plus expected value of x times the probability that he choose that second door, and the probability he chooses the second door is 1 over 3. Yeah, right there. Finally, the expected value of x given he chooses door 3 eventually makes it back to the dungeon, but that's like starting over, so this will be 6 plus his starting over expected value e of x, and that will also be multiplied by 1/3. Now take a look at that equation. That equation only contains a of x, which is what we wanted down here in nightmare scenario. So at this point all we have to do little bit of calculation. A of x is equal to 6 times 1 over 3 is second sorry, pardon, 2 1 over time 1 over 3 time 1, and then you have an e of x. Oh, I have a mistake, sorry. There should be, I'm sorry, I haven't got a eraser. There should be 9. I'm so sorry. Yeah. So I'm not sure. I'm sorry. Yeah. No. This right should be 9 being plus e of actual probably that, but I messed it up. Okay, so this is 9 multiplied by 1 over 3, which is 3 plus e of x divided by 3, and in this case you can see you have 2 plus 1 plus 3 plus that's 6. Here yeah, solve that. Yeah, expected value of yeah, I'm so sorry, I'm confused, and that is the expected time to escape. No, if we are nervous, and no, there's maybe some good reason to be nervous, we can also simulate this. We can use simulate there, because I use simulate a little bit calculation, and we can solve etc etc.